writing an equation of a hyperbola using given info. All right, just a few problems where we're given some info and we need to write the equation of a hyperbola. So for example, find an equation of the hyperbola having foci, I'm going to highlight this, having foci at -1, -4, and -1, 0, and vertices at -1, -3, and -1, -1. So we want the equation of the hyperbola. That is great. I'm going to draw what we have first. I'm going to draw the foci. I'm drawing the vertices. So -1, -4, there's one of those. And then -1, 0. There's another focus. The vertices are at -1, -3, -1, -3, and -1, -1. And that's what we have. So the first things first, I notice that the foci and the vertices are up and down from one another. And that means that we have a vertical transverse axis, which means y comes first. So vertical, I'm just going to say TA for transverse axis. That means y is going to come first. So we have something like this, y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. So we need a squared, b squared, h, and k. Now, the center should be smack dab in the middle of the foci and the vertices, which is really easy with this one, right? This would be smack dab in the middle, right? 1 unit up for the vertex, 1 unit down for the vertex, 2 units up for the focus, 2 units down for the focus. So the center is going to be at -1, -2. So h will be -1, k will be -2. So k equals -2, h equals -1. I'm going to start filling that in. Bring this down here. So this will be y plus 2. This will be x plus 1. Okay, now we just need a squared and b squared. So good news with a squared, because a is the distance from the vertex to the center. And we have that, right? From the center to the vertex, that's 1 unit. It's 1 unit away. A is the distance from the vertex to the center. So if a is equal to 1, that means a squared is 1. Just delete that, put a 1 down there. The next is b squared, and we really don't have enough information to find b squared based on this picture. But, however, be that as it may, we do actually have enough information to find it if we're tricky. A is the distance from the vertex to the center, but C represents the distance from the foci to the center. So each of these foci are 2 units away, 2 units up, 2 units down from the center. So we know that A is 1, we know C is 2, and we have formulas all the way back up here. We have formulas. We need to find B squared. Now, we could solve for B and then square it, but it's a little bit easier to just use the fact that we can solve for B squared. B squared is equal to C squared minus A squared. C squared minus b squared equals c squared minus a squared. So we have b squared is equal to c is 2, so c squared is 4, minus a is 1, so a squared is 1. So b squared is equal to 4 minus 1, which is 3. So I'm going to replace b squared with 3. I want to be very clear. B is equal to the square root of 3. B itself is equal to square root 3. And you could have solved for B and then squared it. That would have worked as well. But I like it easier. It's easier to eliminate the step where you take a square root and then unsquare the root. So we'll leave it there. And there it is. Boom. Easy peasy. This next one's a little more complicated and it's a little, there's some trickery to it. So find an equation of the hyperbola that has foci at negative 5, 0 and 5, 0 in asymptotes, y equals 1 half x and y equals negative 1 half x. I love drawing pictures, so I'm going to do that. Foci right there. I'm going to draw those foci in. So negative 5, 0 and then 5, 0. And I'll deal with those asymptotes in just a moment. Um, First of all, I notice that these foci are horizontal from one another. They're left and right from one another. So because the foci are vertical, not vertical, horizontal, that means we have a horizontal transverse axis. It means x first. So we are going to have something of the form x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. I know that my center should be smack dab in the middle of these guys. And I know that it was like 5 units this way, 5 units this way. Smack dab in the middle is going to be right here. Right there, smack dab in the middle. That's the center. The center is at 0, 0. So we can just get rid of h and k. So it's just x squared over a squared minus y squared over b squared equals 1. Now we need to find a squared and b squared. And you might think to yourself, okay, well, those asymptotes are going to be helpful because if I look at the formula for the asymptotes for a horizontal transverse axis, those are going to be horizontal, let's see, b over a, right? So this is y equals plus or minus b over a times x minus h plus k. And you might say to yourself, awesome, that means that B should be 1 and A should be 2. And that would be lovely if it were true, but that is not true. All that means is that B divided by A needs to be 1 half. But there's a bunch of ways that can happen. It could be 5 over 10 because that simplifies to 1 half. It could be 18 over 36 because that simplifies to 1 half. All we know is that when you divide B and by A, it reduces down to the fraction 1 half. Not that B is 1 and A is 2. So we have to be pretty clever here. And also, I'm going to need to move this over so that I have room to work. What do we know? Well, we know that B divided by A needs to be equal to 1 half. That we know. And if I cross multiply here, A times 1 is A. B times 2 is 2B. So A is equal to 2B. We just need to figure out a way we can use the fact that A should be twice B. We just need to find a way to figure out what A should be, what A and B should be, knowing that A should be twice as much as B. We look at what we're given. We were given these foci. It helped us find the center, but oftentimes it's also help you find A, B, or C. We know the foci are related to the C value. So here C is equal to 5. We know that A squared, or let's do C squared. Let's do C squared is equal to A squared plus B squared. C squared is equal to A squared plus B squared. We know C is 5. We said, hey, A is equal to 2B. And if we plug those things in, right, you have 5 squared equals 2B squared plus B squared. You get 25 equals, make sure to square the 2 and square the B, equals 4B squared plus B squared. So 25 is equal to 5B squared. we can solve for b squared here. So we have divide by 5 on both sides. B squared is equal to 25 divided by 5. So b squared is 5. B squared is 5. B itself is square root 5. B is equal to square root 5, but b squared is 5. So 5 goes down below there. I just need to find what a squared is. So I can take this same formula right here and solve for a squared. So I know that c squared was 25, right? C squared is 5 squared, which is 25. Don't know what a squared is. We said b squared was 5. So to figure out what a squared needs to be, I'm going to do minus 5 on both sides. You'll get a squared is equal to 20. And that is our final answer. X squared over 20 minus y squared over 5 equals 1 is that hyperbola we're looking for. And I want to point out here, we said that b squared is equal to 5, so b is equal to square root of 5. A squared is equal to 20, which means that a is equal to the square root of 20. This simplifies, by the way, to 2 square root of 5. So if we do b divided by a, b is square root 5. A is 2 square root 5. Those square root 5s will cancel, and it does indeed reduce down to 1/2, right? So it doesn't have to be that a was 1 or that b was 1 and a was 2. It turns out a is square root 20 and b is square root 5, but if you divide the two, you still get that ratio of 1/2. All right, so that is it. That's it for everything. That's all there is for me to do here, for you to do here. Now it's just time for you to study, do the homework, and get ready for exam 3, get ready for that final exam. And I guess I won't see you in another video unless one day I decide to make a bunch of videos for calculus and you take me for that, but that's not in my near future. I hope you enjoyed these videos, these worksheets. I put a lot of heart and soul into these. Feeling very proud of it, feeling really great the way that this went. If you have feedback for me or, nice things to say, little hurrah, good job, Professor Cook, I'll take that. And you know what I'll say to you? Good job making it this far, watching these videos. You're doing a great job. I believe in you. And I hope that your rest of your semester is fantastic. I will not see you in another video. Bye.